Hello, this is Ed Close. I'm really excited to be here again on Science and Spirituality TV. The title of this video is Explaining the Unexplainable. But actually, anything that is true is explainable in understandable terms. We only need to find a way to do it. From this point on, we have decided to present the close-snappy theory of everything in two sets of videos, one for those trained in science and mathematics, and one for everyone else. Some of you may want to view both. So the purpose of this video is to elaborate on the previous video and explain the principles of relativity and quantum theory that are basic to Transcendental physics and TDVP, and to explain it without mathematics. Some ideas perpetuated by mainstream scientists are simply wrong. One such idea is that relativity and quantum physics are too complicated for anyone other than theoretical physicists to understand. This is wrong. It may take a while for the general public to understand new science, but if it's true, I believe the average person is capable of understanding it. Reality is ultimately simple. Partial knowledge makes it seem complex. Quantum physics is just weird. No one can understand it. This statement, in some form, has been uttered by physicists from Richard Feynman to most physicists teaching quantum mechanics today. I understand why they say it. They want their students to use what they are teaching them, even if they can't understand it. But what they should be saying is, it can't be explained within the current paradigm. Transcendental physics explains why in the TDVP theory of everything. It is because the current paradigm is missing something. In this video, I will explain everything you need to know about classical physics, relativity, and quantum physics to understand the basic concepts of TDVP in a form that everyone can understand. This will provide the basis for putting the missing something into the equations, making quantum physics understandable at last. Classical particle physics. All you need to know about particle physics is two things. One, except for the extreme conditions like those created in particle colliders and within the interior of stars, the stable elements of the physical universe are made up of spinning electrons, protons, and neutrons. And two, the electron has the smallest mass. I show this slide because it is results taken from an experiment done at the Large Hadron Collider, LHC for short, in CERN, Switzerland. And this is the largest particle collider in the world, and their data is very, very exact, and this is the data we use. Relativity. Einstein said a lot of wonderful things. One of them was everything should be made as simple as possible, but not simpler. And in relativity, all you need to know right now is that nothing can accelerate past the speed of light, which is 186,282 miles per second, and two, mass and energy are just two different forms of the substance of reality. And their relationship is defined exactly by E equals mc squared. Now, I know I promised no math, but I think everyone has seen this equation. Quantum physics. The dream stuff is made of. This is said often because it doesn't seem to be stuff when you get down to the quantum level. There's no matter. It's energy, and then it's something even more subtle than that. So it's called the dreams stuff is made of, quantum physics. You need to know a little more about quantum physics than about particle physics or relativity at this point. First, mass and energy only occur in multiples of some basic unit. Second, protons and neutrons are made of two kinds of quarks. That's a new word maybe for some people, maybe not. It's just a made-up word, and there are up quarks and down quarks. Those are the only kind of quarks that actually make up ordinary matter and energy. Okay? And third, because the physical world is quantized, in other words, it only occurs in multiples and integer multiples of those units, elementary particles always consist of whole numbers of basic mass energy equivalent units, never fractions. The fourth thing you need to know about quantum physics is the fact that elementary particles are non-local until observation or measurement is made. This fact, verified by many, many very careful experiments, is perhaps the hardest thing about quantum physics to understand. What it means is that the substance of an elementary particle, like an electron, is spread over all available space like a vibrating field until an observation or measurement is made. In observations, energy is condensed into a rapidly spinning object. TDVP, Transcendental Physics. All you need to know at this point about this is 1. Electrons, up quarks, and down quarks are made up of whole numbers of basic units. 2. Since the electron has the smallest mass, we can set the mass energy equivalence of the electron equal to 1, and then, based on the very precise statistical data from the Large Hadron Collider, the up quark consists of 4 mass energy equivalence units, and the down quark consists of 9 mass energy equivalence units. Electrons and quarks, protons and neutrons, considered as multidimensional distinctions, are treated by the mathematical logic of the calculus of distinctions, a new method I developed specifically to deal with elementary particles. The calculus of distinctions will be discussed in more detail later. Measurement. Mass, energy, and volume are the measures of the physical universe. Because mass and energy are quantized, the mass of any particle is a whole number of multiple of the mass of electrons. So measurements in basic units, for measurements in basic units, there will be no fractions. Einstein proved mass-energy equivalence by showing that 1 unit of mass is equivalent to a large number of units of energy. By combining verified principles of classical physics, relativity, and quantum physics, we can define the basic measurement unit appropriate for measuring all physical objects. This is made possible by a very interesting thing about relativity that we mentioned earlier, the limitation on the speed of these spinning objects. So, in defining the most basic unit, we see that as the volume of the spinning electron occupies the space, the volume or space of the spinning electron. As that shrinks, its velocity increases, and because of the relativistic limit of motion to the speed of light, the free spinning electron shrinks to a minimum volume. Now, this can be understood very simply using the following analogy. When a skater spinning with arms outstretched, like in the picture on this slide, pulls his arms in, reducing the symmetric volume occupied by his spinning form, his spin is accelerated, and similarly, when a spinning electron is stripped from an atom, the volume it occupies is reduced from the volume of the outer shell of the atom to a much smaller volume of the free electron. And the velocity of its spin is greatly accelerated. Calculations show that the rotational velocity of the electron reaches light speed before the volume shrinks all the way to zero, and because its velocity cannot exceed the speed of light, the free electron can only shrink so far to that non-zero volume. Setting this minimum volume equal to 1, we have the true unit, a truly basic standard of measurement for everything in the universe. This true unit, a spinning mass energy volumetric value of 1, is used in TDVP as the basis for the true unit analysis of every elementary particle and every atom of every element in the universe. True unit analysis reveals exciting new information about the nature of reality, including the discovery of a third form of the stuff of reality, and explains how facts and observations that are not explained by the current paradigm. It explains facts and observations that are not explained by the current paradigm. Here in plain English is what you need to know from this video in order to understand the next video. This is a summary, and it's a repetition, but because some of these ideas are new, I'm repeating them here in a condensed form as a summary. Matter and energy are two forms of the same thing, occurring only in whole number multiples of a basic unit, no fractions. Just three particles, electrons, protons, and neutrons, composed of units of mass and energy, make up all of the elements of the physical universe. But quantum mechanics experiments tell us that something is missing. Protons and neutrons are spinning particles composed of subunits with two different masses. These subunits are called up quarks and down quarks. Since mass is quantized, quarks composed of whole numbers of quanta of mass are also quantized. Thus, there are no fractional particles. Fifth, based on Large Hadron Collider data, up quarks are composed of 4 quanta mass and down quarks are composed of 9 quanta of mass. 6. Relativity's speed limit, the speed of light, applies to the mass of the spinning electron, defines the most basic mass energy volumetric unit. This unit is called the Triadic rotational unit of equivalence, or true unit for short, and is the basic unit used in a new quantized math called the calculus of distinctions, which reveals that something that is missing from the current paradigm is symmetry required for stability. This is corrected by putting true units into the equations of physics. So, coming attractions are true units, explained in more detail. Fermat's last theorem, a famous math theorem that for the first time ever is applied to quantum physics. And the third form of reality. So I hope I'll see you next time on Science and Spirituality TV. Goodbye for now.